so that one is sec squared x. Let me just copy that. And sec squared x.
Do I have to do that whole proof?
You might not. I'll check the exam questions before we go down that road. Yeah, it looks like you don't have to. Okay, how about these?
Tank kx dx. Okay. Differentiate y equals x tan 2x. So that means that's equal to 2 tan 2 sec squared 2x. And then for b, y equals tan 4x. So y is equal to sec to the 6x.
Hold on. Part A is a function of x times another function of x.
Did I do it wrong?
It is product rule.
So v dash u minus u dash v. So the differential of x is just 1.
Yep.
Then we found that with the other one. Let's rewrite this. Okay, so dy over dx equals, so we could do x tan 2x.
No.
Is it always v dash u first?
Okay. You did u times v. It's either one or the other.
Yeah. So x 2 sec squared 2x.
Yeah. I just wrote it as 2x instead of x2.
Yeah. And then is it minus u dash v?
Well, down here it says the quotient rule is minus.
So then it's minus. Yeah.
Which rule are we doing?
We're doing the chain rule, product rule.
The quotient rule is minus. The product rule is plus.
Okay. The chain rule, what is it again?
It is the derivative of the function times the derivative of the function inside the function.
Yeah, okay. So then this second part is just plus tan 2x.
Hang on a second. So tan 2x, yes. Tan 2x. And yes, part B.
So y equals tan 4x. So since there's no coefficient of x in front of it, it becomes y equals sec 6x, sec to the 6. Or does it? Do you have to differentiate the line?
I don't think you can do that. So y is the same as tan x to the power 4, basically.
Okay.
How do we differentiate this thing?
So then we do 4 tan x to the 3.
4 tan x to the 3, and then yes.
Yeah. And is that it?
Then it is times by the derivative of the function inside the function.
So derivative of tan x?
Yep.
Which is just sec squared x.
Hopefully. Let's take a look.
So that one was the chain rule, yeah.
Yeah. So that one's correct, and then this one was 2x x squared 2x plus tan 2 x. That's it. Great. Any questions there?
No, I got it.
Okay. Try that one. I'll just be a sec.
Sure.
Sorry about that. Any idea about this one?
Could you think of it as y equals 1 over sine x?
Yeah.
And then sine, how do you differentiate sine x?
So y is equal to 1 over sine x.
It is. Yeah, it is.
What is 1 over x the same as?
X to the minus 1.
Can we use that?
So sine x to the minus 1. And then the differential of sine x is minus x minus cos x, I think.
It's just cos x.
Okay, so not x.
So this one, let's take a look. They just did using the quotient rule. So that's 1 over sine x.
Yeah.
They just said that's u, that's v, and they just subbed it into the quotient rule. But I'm not sure if we'll be asked to do that in an exam question. They might just be showing where it comes from, because that's given to you in the formula booklet. Yeah. So if it's in the exam questions, we'll take a look at it.
Okay. How would I know that 1 is meant to be u in this case?
I mean, it's literally just it's one thing divided by another, quotient rule.
Mm-hmm. Okay.
And then just sub it in. Differentiate this one.
Y equals cosec kx. Oh wait, no, I'm looking at the wrong thing. Y equals cosec 2x over x squared. And they want us. So that could be cosec 2x times x squared, or x minus 2.
You could do that using the product rule.
Yeah, or the quotient rule, I guess. If you just do
whichever.
u. What's the point of all the stuff above? Is that just to show the differential of cosec?
Yep. So they've just taken bits from the formula booklet.
Mm-hmm. Okay, so with this one, it would be u over v, which is equal to v times u dash minus u dash times v over v minus u, I think it is.
V u dash
v squared
over v squared.
V squared. Okay, so it would be x squared times minus 2 cosec 2x cot 2x, that's a big number, minus v dash u, which is 2x times cosec 2x, and that's all over x squared, well, which is x to the 4.
Yep. And I wouldn't worry about even simplifying that anymore. I suppose you could.
Mm,
Let's just put it as x to the 4.
sure.
Because then, if a different question, they might ask you find the gradient and you just sub in some value for x.
Would we need to simplify it?
I don't think so. They went to whole and cot.
Yeah, there's a cot after the cosec, the first cosec.
No, cot 2x, was it?
Cot 2x, yeah.
Sorry, I forgot it. No, I wouldn't simplify it because then to find the gradient, you would just sub in the value for x.
Sure.
And in fact, you can't simplify it. They just... Oh, you can simplify it a little bit. You can cancel 1x from top and bottom, but that doesn't seem like it's worth it.
Why couldn't you cancel both of the x's, so the x squared, and make it just over x squared?
You have to have an x squared in this one as well, so you can cancel that.
Yeah.
So
Yeah,
you
I
get
see.
rid of one of them. But you might make a mistake doing that. That's why I'm thinking. Don't
Just-
do that. Just leave it
okay.
as it is. Yeah.
I'll do that.
How about B?
B. Sec to the 3x. And they want it differentiated, so that's just equal to k sec kx tan kx. So sec. Oh wait, no. Would we write it as the bracket sec x cubed, and then do the chain rule, I think it was,
Yep.
where it's so then it's equal to 2 value cubed times.
What would be the derivative of this? If it was just x cubed or something?
If it was x cubed, it would be 2x to the 3.
No. It would be 3x to the 2.
Oh, 3x to the 2, yeah.
Okay.
And
So-
mixing up integration. So yeah, 3x to the
Just
2.
had to check that. Okay.
Squared. And then you differentiate the inside, which gives you the sec x tan x. So it's 3 sec x tan x squared.
Why is it squared?
Oh no, I was no.
What do you do with these two?
Do you multiply them?
Yeah. And same thing. So this is the same as 3 sec squared x. That means the same thing.
Yeah.
Tan x. Maybe it might be easier to simplify that to 3 sec cubed x tan x.
But it would be fine if I left it 3 sec squared x times sec sec x tan x.
Yeah. Maybe something that simple. It might be even simpler for substituting later.
Okay.
Any idea about this one?
So the rule dy of dx equals 1 over dx. Differentiate arc sine arc over tan. Show derivative of arc sine is 1 over root 1 minus x squared. So they're saying that so arc sine is sine to minus 1. They want to find 1 over dx over dy. Could you just differentiate it normally and then do 1 over?
Yep.
So sine, or dy dx of sine which is equal to cos x, I think it is.
I'm not sure about this one. So if you had y equals... I'm not quite sure about this one at all. So this is the let part. Okay. Let y equal arc sine x. So that's what I thought we might have to do. Let y be equal to arc sine x.
Mm-hmm.
Do we sine both sides? Yes. So sine y equals x. And do we square? Okay. Sine squared y equals x squared. Is it... oh, hang on. No, we don't need to do that. Maybe later. But then we can just do... yes. What's dx by dy?
So of that, it would be cos y equals 1.
Well, dx by dy is cos y.
Okay.
And so dy by dx?
Is it 1 over cos y?
Mm-hmm. What is y?
1 over cos y. Y is equal to arc sine x.
Mm-hmm.
Cos arc sine x. Which is equal to 1 over cos times sine to minus 1.
I don't know about that. Well then.
Mm.
So at this point, okay. Hang on. Before we do that, is it? Yeah. Oh, okay. Oh, gosh. Nothing about this was intuitive.
Huh.
So we have to get rid of y. The way we do it is using sine squared x plus cos squared x is identical to 1. And so using y? Yes, using y. Okay. And so what is cos... make cos y the subject?
So then cos y equals 1 minus sine squared x. So cos y equals root of 1 minus sine squared y.
Yeah.
I mean, you have to get rid of all sine somehow.
X is equal to sine y.
Oh, so then it's equal to x. How did we get x was equal to sine y? Was it just that we flipped it to the other side?
Sine both sides.
Okay.
And so what do you get when you sub in x?
So then 1 over 1 minus x squared.
So this thing cos y square root of 1 minus x squared. And so dy by dx is equal to 1 over, instead of cos y, it is root 1 minus x squared. So the trick is trick is 1, let y be equal to arc sine x. So we have to make, let it be equal to y. Then you sine both sides. and you get sine x equals sine y, and then you use that substitution. To get to change all the sine y's into x's.
I'd never thought.
They're clever people who prove this. Any questions there?
How would you know once you've got cos y that you need to flip it to 1 over cos y?
Because you had
Apart
dx
from
by
the
dy, and so you flipped it to get dy by dx.
Sure.
That's the only reason why we flipped it.
And how do you know that to start off you need to let y be arc sine x, and then you have to switch it to make sine y equals x?
You're just going to have to remember the let y equal. I mean, that was my instinct.
Yeah.
It's weird to differentiate something without anything else, so I just let it like y equal, and it's going to do dy dx.
If you've got an arc sine,
we don't know the derivative of arc sine, but we do know the derivative of sine. So maybe you think it just put it as sine instead of arc sine.
Okay, I'll remember that.
Tricky. Well, I hope you remember it. I might not. Okay. So using that, try this one. Let's be a second.
Sure.
Is there any ideas here?
So I would think that you would. So it gives us what arc sine is. So we do the chain rule, I think.
Arc sine x squared. Yep.
So arc sine, x all squared. So that is 2 arc sine x times 1 over root 1 minus x squared. And then
you could bring that together. Yeah.
Yeah, so 2 arc sine x over the root.
What were we asked to find here? We're asked to find dy dx. Yeah. So it'll be 2 arc sine x over root 1 minus x squared. I have something weird.
T equals x squared.
Hang on, is this the right thing? Arc sine. The arc sine of x squared. Oh, sorry, it's not sine squared x. This is the arc sine of x squared.
So there's a difference.
Yes. If it was the other way around, the squared would be like here.
Sure.
Or it would be in a bracket like that. It's all squared.
But that's just for x. In this case.
Yeah, only the x is squared here.
Okay. Well, having seen what they said, I guess you make x squared into a single variable, so t or whatever.
Okay.
So then you can just do 1 over root 1 minus t squared.
Well, this is x squared.
Mm.
So what are you trying to get the derivative, is it? Oh, you're doing the t part. So x
Mm.
sine t would be 1 over 1 minus t squared. Okay.
Um, uh, I don't see what more to do considering you've got x that's already implemented in the equation.
You invented t, so you have to uninvent it.
So you make it 1 equals the root of 1 minus x to the 4.
Or um, do we have something else here? Yes. Times by the derivative of the function inside the function.
Wow. Is that the function inside the function though, considering it's something else?
Yeah. It's
Oh,
like
u
sine
and v.
2x or something like that.
So it's the product rule.
No, chain rule. Function inside the function. X sine has no x.
Oh yeah. Okay, so this first part that we've done, 1 over root 1 minus x to the 4, that is the differentiating of what?
Honestly, we didn't need to let it be t and unlet it. I think we probably could have done it without it.
Sure.
It's just x squared squared, and so that's x to the 4. And then times the derivative of the function side function.
Okay. So that would be the 2x.
Yep. And so I believe that's it.
Could you
Yes.
just explain the because usually when we do another one, it's like it's fairly clear that there are two variables when using the chain rule.
So it's
Whereas,
like the sine of 2x. Let's say the sine of 3x. That is the chain rule. With sine, if you put it into your calculator, it will put brackets around it.
sure.
It's not sine times 3x, it's the sine of 3x.
So to differentiate that, what would you do?
So the derivative of this, well, it would be cos 3x,
Mm-hmm.
and then times the function inside the function.
Okay. Okay, that makes a bit more sense.
Yeah. So
Yeah.
sine x sine, it's not times x squared, it's just of x squared.
So you do the derivative of the whole thing and then just the bracket.
And then times the derivative of the bracket, yeah.
Yeah. Okay.
Wow. And arctan. Excuse me. Arctan. Okay. How do we do this one?
Okay. Arc 1 minus x plus x. Okay, so it's the chain rule again.
Yep.
So the second part, the fraction, looks a bit odd. Could you rewrite it as arctan 1 minus x times 1 plus x and minus 1? Or would that make it too complicated?
We could do what we did in the last one, where you just let it be equal to t or something, and then just unsub it at the end.
Okay. So arctan t.
Mhm.
Yeah, t is equal to 1 minus plus x. So then it's arctan t times 1. So just be arctan t. I don't know if that's
Yeah.
right.
Yeah.
Except it wouldn't be arctan t, it would be the differential. So it'd be 1 over 1 plus x squared.
Or I believe, sorry, t squared.
T squared, yeah. 1 over 1 plus t squared, which then becomes 1 over 1 plus 1 minus x over 1 plus x all squared.
Mhm.
And then that would be times the differential of t, which would be, would you do it, is it done numerator then denominator?
You have two x functions in a fraction, one divided by another.
You can cancel them out.
Quotient rule.
Yeah. U over v. So then it's v u dash minus v dash u over v squared, which is 1 plus x times minus 1 minus 1 times 1 minus x all over v squared, which is x squared plus 2x plus 1.
Don't expand it.
Okay. 1 plus x squared. So here we can see that there's a 1 plus x. Could we cancel that out?
Just keep it simple. Expand both brackets.
Okay. So it would be minus 1 times minus x. No, minus 1 plus minus x. Minus 1 plus x. And then over, will we expand that now?
No.
So then 1 plus x squared. And then would you factorize the top or just leave it as is?
What does it become when you simplify it?
Simplify the top.
Mm-hmm.
It becomes minus 2 over 1 plus x squared.
Yep.
So then you multiply those two together, so it becomes 1 plus x squared over 1 plus...
Hold on. Over?
And I'm multiplying that.
So our first one was 1 over 1 plus t squared.
Mm.
And that's times minus 2 over 1 plus x squared.
So minus 2 over the multiplication of that.
Yep. And I wouldn't bother. So just
So
in the
just
bracket 1 plus x squared. And then And that times 1 plus x squared. And, part B or part C might say find the exact value of the gradient or the dy by dx, and you would just sub in the x into there. And so you have 1, 2, 3 x's to sub into. If you expanded that, it'd take a long time, and at the end of it, you'd have lots of x's to sub into, an x squared, all sorts of stuff.
Okay.
Any questions there?
No, I got it.
Okay. Tricky. I suppose. Ooh, it simplifies greatly, does it? Okay, so when you fully expand it, it simplifies greatly. Good for them.
Would I simplify it only if it asked me to?
Yes, absolutely. And in fact, a lot of exam questions specifically state on those ones you do not need to simplify your answer for that very reason.
Okay.
So we're going to try that. I just want to... Just be a second.
Okay. So, first thoughts are quotient rule again.
Yep.
And I wouldn't change, I wouldn't make anything into t terms or whatever.
Yeah, I don't think it would help.
So, v u dash minus v dash u over v squared. So, cos x sine x times nothing. It's different.
0?
Would it be times 0?
Yeah, nothing wrong with that.
Okay. Minus the differential of cos x sine x. Would that be the chain rule? Because there are two... No, the product rule, because there are two x values.
Yep.
So minus bracket cos x, then the cos x plus sine x minus sine x. Is that the differential of cos?
Yeah, that's it.
Okay. And then that's times 1. So yeah, it can be left as is. And yeah, that's subtracted from cos x sine x. Oh yeah, which is 0. So yeah, nothing. And then that's all over cos x sine x squared.
Squared.
Yep, like that.
Yep, I'm happy. Part B.
Part B, determine the number of stationary points on the curve. So we need to make this whole equation equal to 0. So dy by dx equals 0. And then we want to find x, but there are so many values of x.
Something divided by something equals 0. What does that tell you?
That the bottom is, the top is 0.
Yep.
If the bottom is 0, it's undefined, right?
Yep.
Does that mean that it doesn't exist?
Sorry?
Does it mean that it doesn't exist? Or what does it mean?
It's undefined. Can't define it.
Okay.
You can think of infinity if you like. It's something like that.
Okay. So it would be 0 over cos x sine.
Hold on. So basically the top is 0.
Yeah.
So the top alone is equal to 0.
Mhm.
What is the top?
The top is the minus cos x plus sin x minus sin x.
What's cos x times cos x?
Oh, so cos squared x
Keep going.
minus cos squared x plus or minus sin squared x,
And so
which looks familiar.
this is what we have to solve.
Not the bottom part.
We know that the top must be equal to 0.
Sure.
So here's the top. It's equal to 0. It has x in it. We can solve it.
Okay. Would we multiply out the bracket first?
Yep.
So minus cos squared x plus sin squared x equals 0. Then we bring over the cos, so sin squared x equals cos squared x, and then we can bring in the sin squared 1 minus sin squared x for cos squared x. So instead of cos squared x, we do 1 minus sin squared x. I can't hear you.
Sorry. I have a suspicion about something. Okay, so bring in your 1 minus sin squared x or whatever.
So it becomes sin squared x equals 1 minus sin squared x. And would you just sin squared x plus sin squared x? Equals 1. Is that just simplified to 2 sin squared x equals 1? So then sin... Would we want to get rid of the squared or the 2 first? Because it could be sin squared x over a half equals half.
Yes. Reverse order of business is usually the easiest way.
Okay, so sin squared x equals a half, and sin x equals root of a half. So then x equals arc sine root half.
What is the square root of a half?
Something that could be positive or negative.
Yeah, plus or minus.
Yeah. And at the top it defines it between 0, x and pi. So I'd need to solve this in radians.
Yeah.
So that is okay, so arc sine root of a half is equal to a quarter pi, so plus minus quarter pi. But since it's in the positive segment, x equals quarter pi, or pi over 4.
X is pi over 4.
Why is it only 2 marks, considering there's more to it than there was in the previous question?
Well, because we solved it. They just wanted the number of stationary points. So we could have done b squared minus 4ac, I believe.
Yeah. How would we have done that?
So number of stationary points is 2. So they chose pi over 4 was our one. Was it pi over 4? Yes. But then we
Yeah.
have to get our second answer, which is
Plus 180 degrees, so plus pi.
180 minus first answer.
So pi minus.
Yeah.
Yeah. Pi. Oh, it's just minus. It's just 3 over 4 pi.
Yeah. So 1/4 pi, 3/4 pi, and so it's 2. 2
So 2.
stationary points. And let me just check. They did a similar thing, except so they got to this point, but they flipped both sides. So I was thinking this as well. It will be no more. I prefer your way of doing it. Nope, it's just punishingly long for 2 marks.
Mm-hmm.
And then, how about C?
C. Find the equation of the tension at the point where x equals pi over 3. The answer is 1ax plus by plus equals 0. So we could just substitute in pi over 3 for x in our big equation, and that will give us the gradient at that point.
Yep.
And then we look at the original equation, find y, and then we do y minus y1 equals x, mx minus x1.
Yeah, and what is x?
X is pi over 3.
Yes. And am I right in saying you'd be okay for that one?
I'd be pretty sure,
Yeah.
so long as I don't make a mistake putting it in the calculation.
Let's see. Okay, so it is a show that question for cosec. Is this worth doing?
Yeah.
Alright, let's cover it.
So y equals cosec x. So show that if y, then dy dx equals minus cosec x cos x. So we do y equals 1 over sin x
Okay.
to start. And then that's u over v. And I presume if you just follow the quotient rule, then you will eventually get to minus cosec.
Yes, and you can use some of the stuff to help you. So the derivative of cosec is, no, they gave us that, but if we had to, let's see. Okay, so if you needed to, you could use the other ones. Yeah, I think you'd be okay. It's
Okay.
just follow the thing. Yep, quotient rule. Solve this. Is this? Oh, I think you'd be okay for this one as well, am I right?
That one is sec, so it's 1 over cos.
Yep.
And then, yeah, continue with that. Okay, yeah.
Oops.
Does further differentiation include differentiation of e and ln?
Sure does. That's what you're looking at.
Oh, yeah. Okay, so f of x equals ln cot 2x. Show that f x is equal to minus 4 cosec 4x.
And that's f dash of x.
Yeah. So that's the differentiation of that. I'm not sure. Hmm.
It looks like it's chain rule. So the function inside ln is cot2x, and the function inside cot2x is 2x.
Uh-huh.
Um,
So how do you differentiate ln? Is it just 1 or 1 over root 1? I can't remember.
ln. Yeah, I believe it will just be 1 over. Is it 1 over the magnitude of that?
I'm not sure.
I think it might be 1 over the magnitude of cot2x. What would you do next?
So 1 over magnitude of cot 2x times the differential of cot 2x,
Yeah.
which is cos over sine. So it'd be cos.
Hold on.
They give it to us.
They give it, yeah.
So minus cosec squared x. Should we not implement in the 2x with it?
Sorry, yes, sorry. 2x.
Yeah. And is there... Which rule was it where you had to put the multiplying thing in front as well? It was k cosec, whatever, kx.
So that's up here. That's tan kx.
Okay. So minus cosec squared x times 2.
Yes.
The magnitude of cot 2x.
And if it helps, we'll just be dealing with cot 2x.
Cot 2x, so then minus cosec 2x again. Oh no, we don't differentiate that, do we?
No. Simplify. Or what is cot?
Cot is cos over sine.
Yeah.
So
What is
2.
What is 1 over cot?
Oh, it's just tan.
Yeah.
So then, yeah, this becomes tan 2x. Times minus cosec squared 2x times 2.
And I'll just put the minus 2 at the front.
Mm-hmm.
Any idea what you do next?
So we found a chain rule, and we want to get it into 4 cosec 4x. Do we? I know, I'm not sure.
2x. Tan 2x. We go to our formula thing. Tan 2x is the same as tan x plus x.
Tan 2x. I don't get that.
So let me just manage this. Right. So x plus x is 2x.
Sure.
So a is x, b is x. And so you
So
sub them
that. Oh. Okay. So minus 2 tan x plus minus tan x. I don't think I've used this formula before.
Okay.
1. Is that the mean? Oh no, it's just plus minus.
Tan x plus tan x is 2 tan x.
How do we know that we want plus in this case? Oh, it's because it is plus.
Yeah.
Minus 2 tan, so 2 tan x over 1 plus 4 tan x squared, or 4 tan squared x?
Tan squared x, and it's minus. The minus 2 is on the outside. That's nothing to do with it. Minus 2 tan 2x. So I just changed the tan 2x.
Why is it 1 minus?
The signs are reversed.
Okay.
So if you're using plus, on the bottom it's minus. Do we remember our thing? What was it? Sine squared x plus cos squared x equals 1. We wanted tan. And so it's tan squared x plus 1 equals cos x squared x.
I think that's it.
And so that's the same as cos x squared x minus 1. And so that's the same as cosec squared x minus 1. So that's going to be 2 plus cosec squared x. And they're going to cancel some stuff, and you'll be left with this in the end. Somehow.
Why is it 2 plus?
Oh wow. Use trig identities to obtain this. There you go. Thanks.
They help.
What was it, sorry?
Why is it 2 cosec squared x?
1 plus 1. 2 plus cosec squared x. So it's 1 minus minus cosec squared x minus minus 1 from this. Oh, actually, that'll be minus, that'll be plus, it'll be 2 minus cosec squared x. Yes. 2 minus cosec squared x. So tan squared x is the same as cosec squared x minus 1.
Yeah. So 1 minus 1 times cosec squared x. No, plus cosec squared x. Am I saying that right?
Minus cosec squared x plus minus minus 1, so plus 1.
Why is it minus minus 1?
So it's basically 1 minus cosec squared x minus 1.
Oh, I see.
Yeah.
Yeah, okay.
And it'll cancel down or whatever. Snaking us. Yeah, how was that for you, Gregoire?
It was heavy stuff.
Yep. And Moga said something similar. Anything in particular you want for next time?
I'm not too sure. I'll get back to you on that one. It'll probably be statistics.
Okay. Anything in particular in statistics?
I'm not too sure at the moment.
Year 1, year 2?
A mix, most probably. More likely year 2 stuff.
Okay.